Hello, everyone. Thank you so much for joining me for this session. Hope you are enjoying the event so far. So my talk today is about what this long title says. Sorry for not being able to make it shorter, but the idea is how we develop SDKs and plugins and how we can make it easier to share. So that's why the shareable technology. So a bit about me. I am Bruno. I am from Brazil, and I work in the games industry for over 15 years. In the past, I worked on Glue Mobile, Electronic Arts, Aquiris, and since 2020, I work at Ubisoft in the UK. I'm lead software engineer there, and I lead a team that is responsible for all the SDKs and plugins that we develop for all the mobile projects in-house. So our team supports all the projects that we are developing or maintaining live. I also write about game development since 2009, and a couple of years ago I released a book about how to develop an RTS game in Unity. And that's pretty much about me. So the talk today will be divided in three parts. So we start talking about the SDK development itself, then how that applies to the plugin development on Unity, and the last part, how to test, publish, and support, which will be the share part of it. So starting with the SDK development. So the focus here would be how we can make an SDK for Android and iOS in this case. And just to make it more sense, imagine that we are going to develop an SDK that has one API that says hello. So the idea is that the SDK will say hello in different platforms. Okay, but first, before we actually develop the SDK, we need to ask why develop the SDK itself. Most of the time, we are developing SDK because we need a new feature or we need new functionality. Sometimes there is already available on other SDKs, on other solutions. Sometimes there is not available yet. So in this case, it's a good moment to develop an SDK. Some very practical examples in the mobile industry is the constant changes of privacy and rules over the world with new SDKs and new regulations. So this is very useful. So when there is a new regulation or new privacy that you need to take into account in one specific region or one store, usually it's faster to develop your own SDK to do that than wait for someone else to do it for you. Another possibility is to expand or customize libraries. So sometimes you have a library that does everything that you need, but you need to interact with your own systems or your own backend. So you can just use an existing SDK, make a wrapper around it to extend it with new functionalities. Another very important item is the focus on what you need. Sometimes you have an SDK that does 10% of what you need and 90% you don't really need. So instead of having something big in your project that takes some space in the build size, you can make a custom solution for your own problem or your own needs, which usually is faster and more reliable if you are using just one bit of it. And also continuing that, you have more control over the source code. So you don't need to wait for a third party to update a dependency or update something that's not compatible with a new Unity version, for example. You can do it yourself, and it's much faster and easier to test as well. And last, you can have a standard solution. So if you have a studio or multiple studios that have multiple projects, we can have a custom solution made in-house with all the ecosystem of the company and shared across all the studios and projects, which is basically what my team does. So first, the SDKs, they are quite simple. They basically are a very simple app project, and we usually use the Android Studio and the Xcode to develop them. And one thing that is nice about these two environments from the mobile SDK development is that you are not only developed for one specific platform, but you can have the SDK running on multiple platforms. A good example is the Apple framework, that you can have a framework for iOS, iOS simulator, macOS, tvOS, all in the same SDK, all the same code without duplication, and supporting all these platforms. Same thing for the Android, which also runs fine on Amazon Fire devices, for example. So this way you kind of have two SDKs that can reach multiple different platforms. The Android library. Here is a very simple example of one library, which in your case that says the hello method. The Android library can access a lot of the OS-specific APIs that are not available on the engine level, and many third-party libraries. So this is also useful when you need to implement something that's not really available on Unity, but it's available on Android, for example, or even on Java. For example, in this case, you can just bring it to your SDK, implement it there, and then make it available to Unity or even to other engines. One nice feature about the Android itself, the SDK, you are not limited to just Java. You can use Kotlin. You can even use C and C++ inside the library, and you can mix all of them. Doesn't sound a good idea, but make more sense on the Apple environment. But yeah, you can do that if you need. And you have everything packed in one nice R file that you can put inside your plugin and share it, or you can even publish on Maven or something similar, or even just use another project. And because this is still a mobile project, you can have just a simple test application that just call the APIs inside your SDK, which is a very simple way to test it without worrying too much about having to compile the SDK and then test in some other place. On the Apple side, we have the very similar idea with some different situations. So we also have an app that is a project specific for the framework and a project to test it. We also have access to the OS and many frameworks. And you also can mix a lot of different languages like Objective-C, Swift, C, and C++. In this case, it makes more sense because, for example, recently Apple is pushing most of the new APIs and frameworks to Swift. So if you already have some code in Objective-C and you don't want to port or don't have time or don't want the risk to port everything to Swift, you can just implement this new part using Swift and put that to talk with your Objective-C and have it in your SDK. One good example of this is the classical example of this is the Store Kit. So any new API for the Store Kit 2, Apple is only releasing on the Swift library. So if you need a new feature from the Store Kit 2, you might need to add support for the Swift inside your existing Objective-C code. And everything is shared in XC framework. In this case, we need to build one framework per platform. So we have one framework for the iOS, one for the iOS simulator, and so on. And they are all together inside the XC framework. That is the one that you share with your plugin. And another detail, you can have, you can have the framework as a dynamic or a static library. And that is a big difference on how you use it, especially on Unity, but we'll talk about this later in the plugin section. Some potential issues. Working with the SDKs have some constraints. So although, for example, Apple releases a new Xcode every year, usually you don't update it as soon as possible. One example of this is Apple usually releases the Xcode in between July and September, and only make it required to use it to publish on the next April. So you have a moment that two different Xcode versions are usable. For games, it doesn't make much sense. Much difference. You can export from Unity on any version of Xcode and compile, but for SDKs, make a huge difference. Because, for example, if you modify a code on Xcode, the latest version, and you compile in the old Xcode, it won't compile. It have a lot of different errors. So for that reason, we don't rush updating it. We always test on new version. We always rely on CI to test on multiple Xcode versions, but we keep the work on the lowest version that is safer to the development. Same thing for the Java SDK and Gradle plugin. Although there are much higher SDK versions and Gradle plugin available for the app development, Unity, for example, is not using the latest one, and the base Unity version we use as a foundation for all the SDKs is the 2021, which uses Gradle 7. So we make sure all the SDKs for Android compiled with the Gradle 7. So if you're using a different Unity version, it still work, and we test that on CI as well. And on top of that, some best practice. So like I said, we always have a minimum for the dependency, a minimum version of the libraries, the SDKs, the Unity version. And we could ask the project to just update it to the latest Unity, to the latest SDKs, Xcode, and etc. But that's not how we work, because we try to minimize the changes for the game team. And especially if you work on a large project or a large team, it's not easy to just say update Xcode and then expect to like 15 different projects or 5-6 different studios will do it on time. So for this reason, we try to make it we only upgrade when it's really required. We always have a test application inside the SDK project because it's just easier to test, even on CI, or if you are automating the tests or testing on devices. It's very easy and fast to test all the SDKs, and also expose only what is required. So, for example, Xcode tends to have all the header files as public, so you don't really need to send all the header files to your plugin or to the developers. You can just pick the ones that are really required and make it public, and all the others as private, for example. And since you have the application inside the SDK, it's nice to automate all the build process with tests as well. Both Xcode and Android Studio, they have amazing test suites that you can use to build tests. And if you put all together, like build test and test with the tests and then tests in the devices, you can have a very reliable pipeline to test the SDKs. Now, talking about the Unity plugins. So the Unity plugins in this case is the code that will consume all those SDKs. It consumes the libraries, and it's the one that hides all the small details from the developer, so they don't need to worry about if the code will work on iOS or Android, if they need to do something different. So it's one code on all platforms that are supported. On the Unity side, we also have similar project structure. So we always have the API available and the plugin inside it, and we kind of separated the package that we are going to publish, which in this case is inside the hello, and outside it we have the editor tests, we have the examples, and anything else that needs to be included. So the plugin is always isolated, and one of the reasons is because with this structure you can use the test scene to test your plugin in the same way as you publish it. The unit tests and examples, they are both for the CI and also to be included in the project. But for this one, I will talk about more later, but we can use the package JSON for the NPM when you publish the package. There is so many nice features that you can use it, for example, to make the examples available without forcing it to be imported in the project. So the users only import if they want to use it. And also, because of we always try to make it very easy to implement any new SDK or any new plugin. We rely a lot on pre and post process scripts from Unity. So this does all sorts of stuff, as preparing the Android manifest, for example, to modifying the Xcode project for anything like capabilities or entitlements. So we try to automate this part of the configuration as much as possible. So in the ideal scenario, anyone using a plugin will just import it from the Unity package manager, and they don't need to do anything else really to use it. And like I said, the package JSON is a very powerful file that if you learn how to use it, you can leverage a lot of stuff from that. We always start with a common API, and this is like a single entry point to the plugin. Same way as I mentioned on the SDKs. This is basically the only part that is visible and accessible for the team implementing the SDK, or the plugin in this case. And all the rest is hidden inside it as internal classes. Only the supported platforms are implemented in this case, and this makes it very easy to extend. So if you need to implement a new platform, that's basically the only place you need to modify, and it will just support a new platform with a new update without having to change the API that is already implemented in the game. And also to make it very extendable, we try to keep all the logic in the SDKs. So most of the Unity plugin, they are very simple and just straight calling the SDKs. So they don't do any logic, they don't mess with any data. So that is all on the SDK side. And it's done this way, so we can also reuse the SDKs for other engines if you want. So all the logic is in the SDKs, and the Unity plugin as just an interface. The Android implementation, the Android and iOS implementation, they have some differences. It's something that you need to take into consideration. So most of the APIs from the Android, when you are calling any action that the user needs to interact with the OS, it's usually called back to Unity outside the main thread, and that can cause a lot of errors and issues. So any code executed in callback from the OS needs to be executed in the main thread, and I'll show you in a moment how it's done. And another thing, always using the activity from Unity. Unity has the default activity that can easily be accessed through their API. And what we usually do is accessing their activity and send this activity to the SDK. So the SDK don't need to worry about where it's running, if it's an app on Unity or other engine running. The only thing that the SDK knows is the SDK needs an activity, and this activity from Unity works just fine for this case. Like I said, the main thread, it's always good to make sure at least the callback from the Android device, in this case, always run on the main thread, so we can do something like this. This is a very basic implementation just to fit the slide. But the idea is that you force the callback to run on the main thread, so it will work nicely. This is a kind of issue that is difficult to track down, sometimes difficult to reproduce, but it happens quite often. So it's a nice thing that we have. We have like a library that makes sure we execute this on all the main thread on all callbacks from the Android. The iOS doesn't need this, but it could benefit from it depending on what kind of UI the user is seeing on the device. This on both Android and iOS is especially required if you're doing, for example, in-app purchase and you have your own solution. So this is required because all the callbacks, they are not in the main thread. On the Apple side, it's a bit more simple than the Android side, but it also requires one specific class inside the SDK. So because how Unity works, it needs a header file, like a C standard header file to access the Objective-C. Although this is a requirement, it's also good because since you have exposed through a header file, it doesn't matter what you are using inside the SDK. So you could use Objective-C, Swift, or any other language. And since you are exposing through a header file, in this case, it will always work. So the Unity doesn't need to know if the library you're calling, the code is Objective-C or Swift. And like I said, all the UI events, it's a good practice to call on the main thread, but not really required. So there's nothing wrong to always do it, but it's always good to check if the SDK is interacting with UI elements or not. And also, never forget the editor. This is something that sometimes is overlooked. On third-party SDKs tend to overlook this a lot. So always have this dummy. You can either have a dummy implementation for the editor, which is basically returning a mock data. So the developers can implement your plugin and test in the editor before making the build. Or you could even have simulation. So you can create some sort of API or even some API that will trigger like a pop-up for the user to choose what outcome or what he wants to do to test on the editor. So this could be very simple or very complex, but the idea here is to make sure the developer doesn't have a hard time implementing your plugin. It doesn't need to wait for the build time or to test on the device to test it. So as soon as it's possible to test the API on the editor is much easier. And also we do this because we cannot test the mobile SDKs inside the editor. Speaking of tests, unit tests are very powerful. Not the default unit test, but the one that you can create to run on the devices. So probably can see on the screen, but all those tests, they are running on attached device to the computer. So similar to the test that you can do on Android Studio or Xcode, you can have these tests to run the API either on the editor or on the real devices. In this case, it's very simple and powerful. So you just need to connect your device to your PC or Mac and choose on the editor where you want to run the tests, and it will run all the unit tests using the real SDK calls in the device. So this is very powerful and very easy to test any implementation. Just remind that you need to define the platforms that you want to support in the test inside the assembly definition file. Otherwise, the test won't work. I won't be able to see it. And also, I think this one is one of the most overlooked features, which is the test application itself. Many third-party SDKs, they usually don't provide a test scene, or if they do, it's very basic, or even use old-style buttons on the UI. That works only on the editor, so you can even reuse it on devices. So it's always good to include a basic but very functional test application. So that example there is it's just an example, but it's most of the SDKs that we have this kind of test application that we have very simple way to tell what is the version. You'll have buttons to call all the different APIs. And you also have some visual logs because that's very useful when you ask for a QC chain to test your SDK. So always keep it simple. You don't need to make something crazy or make even a game inside your SDK to test it. But it's always good to keep it clean because it's something that you are going to use it quite often. So it's nice to have a nice UI to use to test it. And it's also good to have it so you can test on different devices. So potential issues with the Unity plugins. Like I mentioned in the Apple framework, you can have the Apple framework as a dynamic or a static library, and that changes how you use it inside the plugin. all this part can be automated using post-process scripts, but it's something that you need to take into account. And this is something that you could add in your documentation. For example, you need to, if your library is dynamic, you need to bind it in the main target on Xcode. But it's much more useful if you do it yourself with a simple post-process script, so the developer don't need to worry about that. So the more things you can automate and make it easier for the developers using the SDK, the better. The SDK's dependency also can be included in the package. So if you're using, for example, Android, you can have a Gradle file with all the dependencies that your SDK have. If you are using iOS, you could either have the dependency frameworks inside the project, or you can even use Cocoa Pods, for example, which is very, very common. So it really depends. Like I mentioned, the Google external dependency manager is a great tool, but sometimes you want more control, so you don't use it and have your own solution for that. Some best practice on it. So always include the libraries inside the plugin. So if you have a plugin, doesn't make much sense to have the libraries distributed on different ways or different systems. So you can always include all the plugins inside, all the libraries inside the plugin, and just remember to set up the meta files properly for each platform and the dependencies. Also, always develop the plugin in the minimum version supported. So as an example, most of the projects we have live probably are using the least version they have is Unity 2021. And instead of forcing them to upgrade, which is most of the time is not possible, we make sure that everything we do works well on the lowest possible target we have, but also works on the higher targets like Unit 6. But that can all be done in the CI. You don't need to test everything on your own machine. So just make sure that we test we develop on the minimum, but test all in the CI. The test scene is always good to have a test scene that is actually useful for you and for the developers. So every time I'm working on a new SDK plugin, I imagine myself as a developer and if I would be happy using that. So I try to make it very simple and useful. A simple API, a simple interface in the C# in the plugin case. So if you avoid having the logic inside the plugin side, you can have it all on the SDKs, and it will make it simple and easier to update and also to share the libraries. And one that is very important, which is to always have your project ready to build and run. That looks simple, but I saw many projects that are not in this state or need to download dependencies or need external tools. So whatever it needs, make sure a new member of your team or anyone that wants to see your SDK or extend it, make it easier for them to build and run as soon as they have the project. One last thing in this part, C++. C++ can also be used in this case. So you could have a C++ layer calling the Android and iOS libraries. And you could have Unity consuming this C++ layer using something, in this case, like Swig. So Swig is a great tool that generates C# from C++. Not the C# itself, but generates a C# interface to access the C++ library. So you could have it on C++, and why that could be interesting is if you support more than one engine, that's not necessary in C#. You could have one code base in C++ and just generate the files for C#. But that's also might not be very worth it. Depending on what you're doing, it could slow down the debugging process a lot. It could add a lot of complexity to the projects and also make the crash a bit difficult to track down. So personally, we had a moment when we start to move everything to C++, and then we realized it was a mistake because we made this interface much more complex than the SDKs themselves. It was taking more time to build. It was taking more time to run it on a local machine. And it was just making complex so we could reduce the duplication of the code in C++ and C#. So it was a good idea at the moment, but then we changed it. And now most of the plugins we are trying to make it as natively as possible to the engine that is using. So in this case, even though we have some duplication in different languages, since the C++ and C# code, they are just an interface to the SDKs, it's not a big deal to maintain two different interfaces. Yeah. Now the last part, which is the test, publish, support, and sharing it. So one thing that is very important, and it's something that I couldn't really do my job without it, is the CI/CD to test everything you have. Most of the times we develop in one Unity version, we test in one specific Android version and one specific Xcode version. But in the reality, the projects are using many different Android versions and iOS versions and Unity versions. So in our case, we are, since we have it for all the studios and projects that are using Unity, we know what are the Unity versions used, so we can have that on CI. But third-party SDK probably have a much harder time to test it because they might need to support much more versions. So in this image, you can see an example that it's just a simple pipeline running on different Unity versions and different platforms. So we make sure that we test all platforms and Unity versions in the CI, so I don't need to do it locally. Always build all the platforms, so only the ones that we support. So there's not much sense to build for Windows, for example, if we don't really support any API on Unity. On Windows. And we have two different pipelines that are very useful. So one, we call it a preview pipeline. So every thing that we modify in the code and we want either test fast or send a preview to a team that is waiting for it to test. So a just simple commit will trigger this preview pipeline that doesn't run all the builds, just basic tests. And then when we merge the changes in our main branch, we run all the possible build tests. The difference here is between the preview pipeline we have is something that is done in less than 2 minutes, while the full build is like 30 minutes. So we have, so you can move fast. We always use this approach, so we can deliver more previews for the users. And this is all running on Mac Minis, which is, in my opinion, is one of the best building machines you can have. Is the $500 Mac Minis. You don't need much more than that for SDK development and for the CI. Also, the automation tests. So in the CI, you can run all the automated tests from Unity, from the Android Studio, from the Xcode, and depending on the CI you are using. So these images are from GitLab. So depending on the CI you're using, you might have a nice UI that shows you for each version how long it took to run the tests and everything else. And you can also run the tests on real devices connected to the build machine, or even to simulators running on the build machine. Since these tests are very simple because they are simple APIs, or the test application itself is very simple because they just have a few buttons to test the APIs. It's very easy to automate this part and test it. And then when you are ready to publish it, there are some different ways to publish, but the most common way is using an npm package, which is what is in the package manager for the Unity. The package.json file, like you can see on the right side, it's very powerful and has so many cool features that are hidden, but you can use it. So one of my favorites that we use a lot is the hidden folder. So what we do, if we have files that we want to be in the plugin, but we don't want the user to import it unless we want that, we store in hidden files with the tilde. So every Unity folder, if you put the tilde, Unity won't see that. But you can include that in your plugin and publish that in your package. And using the package manager and the package.json, you can have like a samples key that is there. With that, you can have a button to import the samples from the package inside the project. So this is nice because unless you really need the examples, you don't need to force the user to have the examples, which sometimes is annoying because you don't want to see like your testing in the build or in the assets for the user. So and they will also find it weird to see stuff that they don't need inside the assets. So this is a very nice way to prevent it using the hidden folder. Also, like I mentioned, we have the preview pipeline. And what makes it different, we always have this preview name with the number of the CI that's building. So we can have many different previews and we can track what previews are being tested. And also that's all done in the package.json. So the package.json is something that you can modify in the build during the build time. So it's most of the things that are like the version, you could just update it on the CI. And then in the package manager, we have different ways to use to include the plugin. So the most common way is the scoped registries when you add a URL and then you import the package from there. You could also use Git repositories, which is basically the same thing, but the difference is that you have the Git URL. The difference between the two is that the scoped registry have much more power to publish and update and see more details than the Git repositories. And one thing that is also good for local tests is the local packages. We had some packages that depend on each other. So instead of making a change and publishing it to the NPM and then moving to the other project to test that, we could just include it as a local package, test everything else, and then publish the dependency and the package that we updated. Another powerful thing for the dependencies in the SDKs is, like I mentioned, we had a situation with packages depending on other packages. But it's always, if you're using Git, it's great to use the Git submodules. So it's also a powerful tool that you could have different SDKs or different projects inside your main plugin, but it's still modular, it's still its own project, and without being a different package. So this is one of the most important things when working with plugins and SDKs, is always supporting prioritize the support over new features. So every time a game team is having problems with SDK or they found a bug or something similar, that has a much higher priority than finishing a new feature for the SDK, because the support for the ones using the SDKs is always the priority. Also, in one way that we can ensure that support is priority is having a very stable pipeline. So like I mentioned, some examples of CI and tests. If you have all of that set up, it's it's very easy to prioritize the support because you have all the tests, all the tooling required to automate as much as possible. So you don't need to worry about having to just changing the branch and starting over. And another thing that is very important and also very overlooked for SDKs is the documentation. It's as important as the SDK itself. Usually, it's common to write the documentation when you first develop the SDK and then don't really update it. So it's annoying to find like APIs that are not are different, or dependencies that are different or not used anymore. So always at the end of the cycle of developing a new feature or changing something in the SDK is good to update the API with examples, with changelog, and if possible, a roadmap as well, because it's nice to know when new features to the SDK will come. And this is the first interaction between the developer and the SDK. So they will first see the documentation. If the documentation is not good, it's confusing, or if the documentation just show the API and doesn't tell how to call it or a concrete example of the flow of the API, that could make it look difficult. It's and sometimes the documentation is the difference between the developer tell the producer that it will take 2 weeks or 2 days to implement your SDK. And that could make a difference for not using your SDK or using your SDK. So the documentation is something that, at least on my team, we have a high priority on it and try to keep it as good as the SDK themselves. And just a nice example, we are currently using Doxaurus. It's from Meta. It's great. Works with Markdown, and it's very easy to set up using GitHub pages or GitLab pages, and easy to maintain as well, and very friendly to developers. And also working on publishing and testing the SDKs. We have some potential issues that can always happen. The first one is very common to happen, but it's different if you are providing if you're providing the SDK or if a third party is providing the SDK. Sometimes you have a project that is using an old version of the SDK and they need to update on dependency or something like that. Usually could say just update to the latest version and that's it. But most projects, they try to minimize the risks. So they don't want to update the whole SDK to a major version. So it's always nice if you have a plan or a pipeline prepared for this situation when you probably need to go back a few releases, branch out, make this change, and make a release. This is very something that happens often, and it's also something that could make a difference between updating or not the SDK. So if you can make a version that has only the changes that's required, it's very friendly to the developer, to the producers will be happy as well, and you have less risks when you publish the build. The CI/CD, like I mentioned and show some stuff, it requires time. I saw many SDKs, many pipelines that they are there just to say they exist, but they are not very well maintained or very they don't cover all the cases. So the CI/CD is require time. If you are in a big team, you probably have one person that is just his job is just to take care of the CI/CD. But in a small team, for my team, we are 3 people, and so the CI/CD is maintained by us. But that's not an excuse to make it as a second plan or something that we just doing because we need it. So it's like the documentation, the CI/CD is as important as the SDK itself, because without it, we can't test, we can publish, we can't ensure that the change that we are doing will work on any Unity version supported. And the last one, if you're working on a team that have few build machines but pushing a lot of changes, and you have a CI that does this kind of preview releases, this is usually something that can slow down the process a lot. So usually, I personally have create a lot of commits, but I only push when I really want to test the preview on the CI. And some best practice, like I mentioned, the CI stability is very important. So any issues that is happening on the CI because of macOS update or something that was not expected, they need to be fixed as soon as possible. So it doesn't make much sense that you are going to fix the CI after you are done developing something, because you're not being able to test what you're developing without the CI. So for this reason, the CI is probably the high priority, because it's not working, you can't really test or publish. Always keep an eye for improvements, especially the build time. There's many things, many strategies that you can do for caching what you have, or make it in parallel builds or not, depending on how many processes you have. So it's always good to keep an eye for what you could improve. Also, you can run multiple jobs in the same machine, but maybe it's not that is not faster. So it's good to compare, have metrics, and always compare how many really is the number that works for your project. And always make sure that any new Unity version is tested. So the way that we have our CI, we can just install a new Unity version on the build machine and add one variable in our CI script, and that's done. So the whole pipeline will run in a new Unity version. And you can also use it to test the mobile library. So if you have, it could look like it's a lot of tests and build, but it really make a difference if you have, if you build the app, you test the app. You build SDK, test the SDK, run the app with the SDK, then do the same thing with the plugin. That could prevent different kind of issues. Good. So to wrap up, some key takeaways. Always keep the logic in the SDKs, so you can make your plugins very simple and easy to maintain. Always keep the plugin simple. So the Unity plugins, it's easy to make it wrong or to make the project go wrong, but it's quite difficult to make it simple. So always try to make it simple. And always ready to build and run. So all the SDKs, when you have SDKs in Unity, like this example, you have many projects. So in this case, we have at least 5 projects, but that could be 10 or 20 projects. So always make sure that all the projects that you have are ready to build and run. Automate everything you can. So automation is great to test, to build, to have new Unity versions on your CI. So that is very important. And the last thing, the support comes first. So if you are maintaining an SDK and a plugin, the support is important as much as the development itself. So everything that I mentioned here is, I hope it could be like a blueprint. So I know most of these items, they are very complex. I could spend a day or a week in one slide just going to the details. But I hope this can be like a blueprint and give you an idea how this process of making SDKs and plugins and sharing it work. So yeah, thank you very much.